Hello students, welcome to the next lecture on the topic analysis of bivariate data under the subtopic correlation regression, and it is presented by Shantala Kulkarni, lecturer, Department of Statistics, Gokti PU College of Commerce and Science. So in today's class we are going to discuss the examples on Carl Pearson's coefficient of correlation. What is the formula we are going to apply, how is the method to solve it, and as it is very much told that it is a bivariate data, so you will be having two variables x and y. So the first example is calculate the product moment coefficient of correlation between the following marks out of 10 in statistics and mathematics of 6 students. So there are 6 students, statistics is represented by x variable and mathematics is represented by y variable. Now before we solve or make the columns, let us see what is the formula we are going to apply here. The formula product moment coefficient of correlation is Rxy is equal to n summation xy minus summation x into summation y, the whole thing divided by n under the square root n summation x square minus summation x the whole square into n summation y square minus summation y the whole square. So if you remember this particular formula, we will see the columns what we have to make. So you have the x and y values, then you have to make x square, y square, x into y. X square is nothing but 7 into 7 and y square is nothing but 8 into 8 and x into y is 7 into 8. So this is what you're going to make the columns. Find the total, apply the formula, do the calculation and come to the conclusion. So when you finally do the calculation, here you are getting the value as 0.8081, which says that there exists a positive correlation of higher degree between x and y. So this is how you solve an example. This is a 5 marks example. Similarly, there is one more example of the same type, but the methodology we have applied is different. Calculate Carl Pearson's coefficient of correlation for the following data. You have different values of x and different values of y. Here the major change, if you remember, every time we have the shortcut method for reduction of calculation to make the calculations more simple. So here also under correlation we are using this shortcut method. We are changing x in the form of u and y in the form of v. So here also you have the freedom to choose any value you want to. Here they have chosen as 74 and for y they have chosen as 25, and then they have made all these calculations. See, if you pay attention, you will easily come to know, because you have already solved examples under dispersion, under measures of central tendency. So you're used to how to doing these examples. Then the next comes u square, v square, u into v. So then when you're using u into v, u and v formula, obviously in place of x you will be writing u, and in place of v you will be writing, in place of y you will be writing v, and the rest all is same. And after all these calculations, you have to literally solve these examples for your perfection. And yeah, so here you're getting the answer as negative 0.9912, which shows higher degree of negative correlation between x and y. Similarly, there is one more example for you all. You can please note down this example and solve for yourself. Calculate Carl Pearson's coefficient of correlation for the following data. Similarly, these values are there, x and y. So if the values are huge, and if it's having a common class, difference between, you can see what they have made here and you can follow the steps and solve it for yourself. And here the answer is perfect one in this particular example, means there is a perfect positive correlation between x and y. So these are simple ungrouped examples. Similarly, there is one more. There are quite a number of examples for you all to solve and become perfect. As your exams are waived off, no issues, but at least for the sake of knowledge, you can solve these examples and it can be helpful to you all. In this particular example, the answer is -1, which we say that it's a perfect negative correlation between x and y. Now, let us see this particular example. Calculate the coefficient of correlation between the number of male children and the number of female children from the following data. This is the question here. The question is here. See, this is a grouped data, this is a group data for x 0, 1, 2, 3, 4, and here y 0, 1, 2, 3, 4. This is a common, number of female children and number of male children together, how it is being. This is a 10-mark question where you have to make a huge table here. This is a table which you change, x is changed into u and y is changed in terms of v. It's as of now, I'm just going to say that you just see the example. Fx are the frequencies, fy are the frequencies of y, u into fx means you're changing u of x and v for y, and then you're making those calculations actually. And the formula what you use here is quite big one. Rxy is equal to n double summation xy fxy minus summation x fx summation y fy divided by capital N summation x square fx minus summation x fx the whole square. Similarly for the y thing you're going to write. Well, it's quite difficult for the explanation part being done on online class. You just remember this thing. If time permits, explanation will be done to you all. Same, one more example of the same type is there. You can skip it, it's fine. So that's what you need to practice is the examples of 5 marks. Now this is a group data where it's a question of 10 marks. So you just go through the tables, see the formula. You need to observe carefully and then apply these things, how the table is, how it is being written and all that. Fy, you have to just pay attention little and then hope it should be understandable to you. And let's see. So yeah, these are the examples of 5 marks and 10 marks under correlation. Solve the examples. So with this we come to an end. Thank you.